rectangular region. Before this, we have in subtopic 4.2, we have a rectangular region. Okay, rectangular regions means all the limits previously. Okay, previously, oh my God. Previously, in 4.2, please mute your microphone. All right. Could you please mute your microphone so that everybody can focus on me? Okay, subtopic 4.2, we have rectangular region. Okay, rectangular region means all the limits are constant. All the limits are constants. Semuanya nombor. Okay? I think one of you did not mute. Please mute your microphone. Okay, hopefully everybody can mute. You can respond when I ask you the question. Okay? All right, so now we will focus on non-rectangular region. Okay, so non-rectangular region, we will have something like this. Type 1, double integrals towards region R. We have fxy, dy, dx. Okay, but now the limit of y here should be in terms of function. Okay, limit of y will be in terms of function. So we have y equals to, let's say we have a function of f1x. Okay. Let's say y equals to, let's say g1x here, and then y equals to g2x. Okay, so we have functions for the inner limit. Right? And then for the outer limit of x, of course, we can have from a until b. All right? So that's the difference between non-rectangular region and rectangular region. Before this, all the limits, inner limits and outer limits are constants. But in this case, the inner limit must be functions. Okay? And then type 2, we will have double integrals of fxy. We have dx first, and then goes to dy. And then the limit for x, okay, the limit of x here should be a function. Okay, so we will have x equals to, let's say, h1y, and then x equals to h2y. And the limit of y, of course, constants, okay, c and d. So the inner limit should be a function and the outer limit should be constant. Okay? So now let's take a look at exercise 4.3. Okay, let us do the simplest question first. And for this case, guys, for non-rectangular region, you cannot just simply switch the order. Okay, later I will teach you about reverse the order of integration. Means when you are given dy dx, you have to change into dx dy. Right? For the case of non-rectangular region, you cannot simply switch the order of integration, but you have to sketch the graph, and then you can reverse the order of integration. I will show the step later, right? So let us focus on exercise first, exercise 4.3. So let us do question number 1. Okay, so first of all, guys, you have to bear in mind, in order to sketch the region R, okay, region R is 100% from this limit. Okay, this is your region R. All right, so in order to sketch the region, you have to refer to the limit. Refer to the limit. Okay, not this function. Jangan refer pada function kat tengah ni. No, just refer to the limit. Alright. So the limit represents region R. You have to bear in mind with that. Okay. So now what can we do here in order to sketch the graph? You have to take out the limit. Okay, guys. Now limit of y. Okay, limit of y. Y start from x squared over 2. Okay, so y equals to x squared over 2, and then another limit of y is x, okay, and y equals to x. So what you should do now, guys, you have to sketch the graph according to these two equations, okay, and then the limit of limit of x is just constants, okay, which equals to 0 and 2. So take out limit of x from 0 until 2. Okay, so let us sketch the region. The region. So we have x and y as this. Okay, first of all, y equals to x squared over 2. So we will have this. We have a quadratic graph, isn't it? And then positive. So it should be an upward parabola. Okay, and then we also have y equals to x. Okay, so y equals to x is just a straight line like this. Okay, so now guys, the region, we use a yellow color. The region should be this. Okay, region should be like that. And then we have when x equals to 0, of course x equals to 0. Okay, and then when x equals to 2, of course we will have y equals to x, so y also equals to 2. So we have this intersection point here when x equals to 2, y also equals to 2 here. Okay, so now guys, for this case we have type 1. Okay, type 1. Why type 1? Because dy dx. Okay, so what you should do now here, guys, listen here carefully. I will use red color. When we have y first means the movement is from bottom to top. Okay, the movement of the region or the limit is from bottom to top. So the region should be moved from bottom to top here, like that. Okay, I explain this because we will use this concept when we want to reverse the order of integration later. Okay, so for this question, it's enough. Okay, so we settle already, sketch the region. So next we can proceed with the integration. So let us integrate this. 0 until 2. We have x squared over 2. And then we have x squared y dy dx. Okay, so we have 0 until 2. Okay, now we want to integrate with respect to y. Thus, x squared is a constant, so you can take this out. And then integrate y squared with respect to y. What should you get?
Y squared over 2.
Yes, good. Y squared over 2. Yes, very good. So substitute with x squared over 2 and then x. Okay, so we have dx here. So now 0 until 2, x squared, just a constant. So we just substitute y with x. We have x squared over 2 and then minus, substitute here, x squared over 2 squared over 2 dx. Okay, so we will have from 0 until 2 x squared minus x squared x to the power of 4. 2 squared is 4. 4 times 2 should be 8, like this. Please take out your calculator, guys. Okay, so 0 until 2, we have x to the power of 4 over 2 minus x to the power of 6 over 8 dx. Okay, and then we can integrate this. So x to the power of 5 over 10, because 5 times 2 is 10, minus x to the power of 7 over 56. So 0 until 2. So we will have this one, 32 over 10 minus 2 to the power of 7 should be, what guys? 128, isn't it? And then over 56 minus 0, 0 lah. Kalau saya ada salah, saya tahu Alright, so if we calculate this, we will get, the answer is, can you give me the answer?
32 over 35.
Sorry, I can hear you. 32
35.
over 35. Okay, good. So is that correct answer? Question number 1. Oh yes, 32 over 35. Okay. All right, next, let us proceed to question number 2. Okay, question number 2. Okay, now we have dx first. Okay, dx first. So limit of x is from y. Okay, so we have x equals to y, and another equation is x equals to square root of y. So x equals to square root of y. Okay, this is type 2. All right, this question is type 2 because the x first. So type 2 dx dy, the movement should be, since x is first, so the movement should be from left to right. Okay, from left to right. Left to right. All right. Previously, we have from bottom to top because dy first. But for this question, we have dx first. So the movement of the limit should be from left to right. Okay. So next, we have y. Okay, guys. Y is from, of course, y is just a constant from 0 until 1. Okay, so y from 0 until 1. So let us sketch the graph. Okay, we have this. X and y. So x equals to y, of course, we will have just a straight line like this. Okay, and then we have x equals to square root y. Guys, if we square both sides of this equation, we have x squared equals to y, isn't it? But now we have square root of y, so we know that x must be greater or equals to 0. Okay, so y equals to x squared. Suppose we have this, like this, isn't it? But since x equals to square root y, so x must be greater or equals to 0. Then what we can do is we can erase this part. Okay, so we will have this region. All right, this region. Okay, and then the movement is from left to right, just like this, left to right. Okay, and then when y equals to 1, of course, x equals to y, thus, of course, x also equals to 1. So when y equals to 1 here, x also equals to 1, like that. So that's the region R. Okay, let us proceed with the integration. We have from 0 until 1, square root of y, square root of xy, dx, dy. Okay, so from here we can separate both variables as this. Square root of x multiplied by square root of y, dx, dy. Okay, now, so what is the constant now? We want to integrate with respect to x. So which one is the constant?
I.
Square root y, yes, okay, good. Square root y is just a constant. So we can take out square root y. All right. So we can integrate this x to the power of 1 over 2. So integrate x to the power of 1 over 2 equivalent to 1 over 2 plus 1 should be 3 over 2 over 3 over 2, isn't it? Like this. So square root of, sorry. So y until square root y dy. Okay, if I rewrite this, square root of y, so this coefficient can be moved here. So we have 2 over 3, isn't it? Oh, sorry, 2 over 3. Because I moved this here. Okay, so we will have x to the power of 3 over 2. Substitute square root y dy. Okay, so we will have 0 until 1, 2 over 3 square root of y. Okay, so substitute x as y to the power of half to the power of 3 over 2. And then we will have y minus y to the power of 3 over 2, like this, dy. Okay, so now 0 until 1. Let's say 2 to the power of 2 over 3, y to the power of half, like this. So 3 over 4 minus y to the power of 3 over 2. And then you have to multiply with square root of y here and here. So we will get, okay, so 1 over 2 should be 5 over 4, isn't it? Y to the power of 5 over 4 minus 1 over 2, so y squared dy. All right. So now we can integrate this. Okay, so 2 over 3, y to the power of 5 over 4 plus 1 should be 9 over 4. So over 9 over 4 is 4 over 9 minus y cubed over 3. Substitute 0 and 1. So we have 2 over 3. Of course, just 4 over 9 minus 1 over 3. Can you give me the answer? Please calculate this. What should you get?
2 over 27.
Yes, 2 over 27. Okay, good. Is this the answer? Question number 2. 2 over 27. Okay, yes. Okay, good. So next, question number 3, number 4. I think it's quite simple. So let us proceed to question number 5. Okay, question number 5. Oh, before that, because sometimes students always got confused with this, so let us do question number 3. Ni. Kenapa students selalu confuse soalan ni? Guys, always bear in mind when we want to sketch the graph, you have to refer to the limit. Okay, refer to the limit. To the limit. So the graph for this question is not a trigonometric graph. No, this is not. You cannot refer to this. Okay, this is not trigo graph. In order to sketch the graph, you have to refer to this. Okay, region R. Okay, region R, 100% from the limit, not the function. Okay, but the limit. So in this case, all right, guys, as we know, we have dx. So x from 0 until y. So x equals to 0 and x equals to y. Okay, and then guys, one more thing. You have to bear in mind when we have x equals to 0, means y exists. Okay, x equals to 0 means y exists. All right, and then for y, let's say I use green color. Y is from 0 until pi. Of course, pi also a constant. So we have y from 0 until pi. Okay, if x equals to 0 is y exists, thus y equals to 0 means x exists. Okay? You have to bear in mind this. Y equals to 0 means x exists. Kalau x equals to 0, y exists. You kena faham benda tu. You have to understand that because we want to sketch the graph. Okay, so now let us proceed. We have this. Okay. X and y. All right. We have x equals to 0 and then x equals to y. So x equals to 0, of course, here, 0. X equals to y, so here. Okay. And then we have, okay, x equals to 0, as I mentioned, is y exists. Isn't it? Y exists. So y exists. This is the y exists. And then we have y from 0 until pi. So y from 0 until pi. Okay, so of course all the bounded region here should be this. Okay, because y until pi. So we will have region R as this. Okay, what you can do now, we can just proceed with the integration from 0 until pi. From 0 until y, we have y cos x dx dy. Okay, so now we integrate cos x. We take out y because y is just a constant. Integrate cos dapat apa? What should you get?
Sin x.
Sin x, yes. Sin x. So substitute 0 and y dy. Okay, so we will have 0 until pi y sine y minus sine 0 dy. Of course, sine 0 is equivalent to 0. So we have y sine y. 0 until pi y sine y dy. Okay, so how do we integrate this y sine y?
Partial integration.
We can use integration by part or tabular method. Still remember tabular method? That's what I show you in chapter 2, tabular method. Okay, so we will have differentiation column and we have integration column. Okay, right now, which one to be differentiated? Either y or sine y? Which one? Kita nak differentiate yang mana? Y, yes, very good. Because we need to use log-pad, isn't it? Log-pad. So polynomial comes first before trigo. So that's why we use y to be differentiated. So we have y, we have sine y. And then we have to differentiate y until we get 0. So differentiate y, we get 1. Differentiate 1, we get 0. So don't forget here plus, minus, plus. Okay, integrate sine y. We will get negative cos y or positive cos y.
Negative cos.
Okay, well done. Negative cos y. Okay, good. Integrate negative cos y, we will get?
Negative sine y.
Yes, negative sine y. Well done. Okay, so next we have to do like this. Okay, so the answer for this integration equals to multiply everything. So y multiplied by negative cos y. So negative y cos y. And then 1 multiplied by negative sine y, so we have plus sine y. And then just substitute with the limit 0 and pi. Okay, so we will have negative pi cos pi plus sine pi minus 0 plus 0 lah, of course. Sine 0 is 0. All right, so negative. Okay, cos pi is negative 1. This one is 0. So we get pi. Okay, we will get pi. All right, so that's it. Okay, let us proceed with question number 5. Okay, evaluate double integration YDA where R is the region enclosed by triangle with vertices -2, 0. Okay, so let us sketch the region R. Region R. We have X, we have Y. Okay, -2, 0 means here. -2, 0. And then we have 2, 0, of course, here. And then we have 0, 2. Okay, let's say here 0, 2. So we have this line, triangle. Okay, so of course, if you use intercept form, this line is represented as a -x/2 plus y/2 equals to 1, isn't it? So basically, this is equivalent to -x plus y equals to 2. And then for this line, we have all the values are positive. So x/2 plus y/2 equals to 1. So x plus y equals to 2. All right. So now, guys, this is your region. Okay, this is your region now. Now, the question did not mention, okay, either dy dx or dx dy. It just mentioned dA. So it can be dy dx or dx dy. Okay, let me show you both. Okay, let me show you both. Let's say we calculate this by using dx dy. Okay, dx dy. So y dx dy. Okay, listen here carefully. When we have dx first, so the movement should be from left to right. Okay, from left to right. Okay, and the inner limit should be lines. Okay, the inner limit should be lines. And the outer limit should be, okay, ni lines, ni lines. The outer limit should be just points. Titik sahaja sebab dia constants. Okay, so from left to right. Okay, left to right. So I will use this arrow from left to right. So the first line, left line is this. Okay, the left line is this line, the green color. Can you see this that I highlighted here? So we have dx. Okay, what happened, guys? Ini saya padam. Okay, what happened now? X equals to what? From the left. Left line here. Okay, from this is the left line. Therefore, we have x equals to 2 minus y. So we have, sorry, this one should be x equals to y minus 2. So y minus 2, the left line. Okay, and the right line should be here. So from this equation, we have x equals to 2 minus y. Okay, so x equals to, the limit should be x equals to 2 minus y. Okay, now anyone can give me the limit for y? Y from where to where? Remember the points. The
0
points
until
on y. Yes, 0 until 2. Well done. So we have from 0 until 2. Okay, so that's it. That's the integration. Or, okay, this is dy dx dy. Or alternative method. Okay, let me sketch the graph again for you so that you can differentiate between dy dx and dx dy. Okay, x, y. This is very important when you want to reverse the order of integration. Right? So we have this. So here should be 2, -2, and 2. Previously we have this x equals to y minus 2, and then here x equals to 2 minus y. Okay. So we will have, okay, let's say for the second method, I'm going to use dy dx. Okay, dy dx. The integration y, isn't it? Okay, yes, y, dy dx. Okay, so dy dx means the movement is from bottom to top. Okay, bottom to top, right? So let I shade this region. And as I mentioned earlier, inside here should be lines. Okay, and then outside here should be points. All right, so the lines, what are the lower lines? Limit for y, lower lines.
X equals to 0.
Y equals to 0, isn't it? Okay, so let's say y equals to 0. Yes. Okay, now what's the upper limit of y?
2.
You cannot put 2 because inside here should be lines. Remember? Garisan, dia mesti garisan. And then dia mesti function, lines. Dia mesti function. So which one you nak ambil? Yang garisan ni ke garisan ni? Okay guys, so now what happened here is you have to divide this region into two parts. Okay, into two parts. So we will have the first part, let's say part A and part B. So part A is from bottom to top. Okay, from bottom to top. So this is part A. All right. So for part A, the upper line should be, okay, this. From this equation, we have y equals to x plus 2, isn't it? Y equals to x plus 2. So the upper limit here should be y equals to, ni saya padam dulu lah. I will erase this. Okay. Y equals to x plus 2. And then how about the limit for x? For part A, limit of x should be from titik, ingat points. X ni titik. Points saja, just points.
2 to 0.
Yes, from negative 2 until 0. Okay? So, kalau you pilih dy dx, dia leceh sikit. It's more tedious because we have to divide by two parts. Okay? So, part B, now part B. Okay, guys, again, we will have this y dy dx. Okay, now the limit of y, okay, y lower up, okay, dy dx from bottom to top. Sama besar apa tak faham pula ni. Okay, from bottom to top, of course, limit of y equals to 0 until y equals to, what's the upper line?
2 minus x.
This, okay, this one. Y equals to 2 minus x. Okay, well done. Very good. 2 minus x. So we will have y equals to 2 minus x. And then how about the limit of y? The limit of x from?
0 to.
Yes, from 0 until 2. So 0 until 2. Okay, so if you choose dy dx, it's a bit tedious because you need to have two parts of integration. However, if you choose dx dy, there is only one integration involved here. So understand between the first method and the second method?
Yes.
Understand, guys? Both will give you the same answer. Just the difference here is you have to combine, okay, A plus B in order to get the correct integration for if you choose dy dx. Okay, alternative method is dy dx. Dy dx. Okay, this one, the first method is dx dy. Okay, first method. Dx dy. So you have to be creative, guys. Okay, you have to be creative. When you look at the region, it's up to you whether you want to solve SD, SDY or DYDS. Both will give you the same answer. Don't worry. Okay, you can try to find out the answer later. Seriously, both will give you the same answer. All right. So next, okay. Soalan tu I just want to explain about DYDS and DSDY lah. Okay, let us do question number 6. Number 6 ni saya solvekan sampai habis lah. Number 5 tadi dia simple je nak function dia kan. So let us do question number 6. Evaluate, okay, sorry, number 5 lagi. Question number 6. Copy. Alright, this one can be deleted. Delete. Okay. Alright, you have 3 graphs here, guys. You have this, y equals to 4 over x. And y equals to x, and x equals to 4. Okay, so let us sketch the graph for this region. Okay, let us plot one by one, x and y. Okay, first, y equals to 4 over x. So your graph will be like this. Positive gradient. Okay, and then y equals to x. So of course, just a straight line. Here, okay. And then x equals to 4. Okay, now we would like to know what's the point here. Oh, sorry. We want to know what's the coordinate here. Okay, before we can plot x equals to 4. So what you have to do is, in order to find the coordinate here, you have to equate these two equations. So y equals to 4 over x and y equals to x. So we will have 4 over x, equate this with, 4 over x equals to x. Okay, y1 equals to y2. So we have x squared equals to 4. Of course, we have x equals to plus minus 2, isn't it? So the intersection here, okay, this I can erase this one, should be positive 2. And then the intersection here is negative 2. Okay, so right now we know that the position of x equals to 4, okay, x equals to 4 should be in the front. Okay, so we will have x equals to 4 here. Okay, so now x equals to 4 is a straight line, of course, a straight line here. Okay, now tell me, where is the region actually bounded by these 3 equations? Okay.
Dekat to 4.
Yes, we have to consider x equals to 4, isn't it? So we will have this region. Okay, this region. All right, so this is our region R. Region R. Okay, now, okay, tell me, how you want to solve this? dy dx or ds dy? Agak-agak yang lebih mudah. Sebab dia tak cakap ni, it doesn't mention dy dx or ds dy. So if you look here, which one you want to use? Dx dy or dy dx? And you have to remember the inner limit should be lines. Outer limit should be points. So which one you think
dy
easier?
dx.
Well done, very good. dy dx. Okay, because since the inner limit are lines, okay, so we will have bottom line here and upper line here. Okay, so dy dx. Okay, very good. Well done. You understand already the concept dy dx. Okay, because both limit bawah ke limit atas adalah lines, garisan. Okay. Kalau if you choose ds dy, you have to break this region into 2 parts macam tadi. So tedious lah. For this question, it will be easier for you to solve this by using dy dx. Okay, so now let us proceed. Integration onto function to xy. Okay, xy dy dx. Okay, now the lower limit. Okay, this graph, this line is represented by y equals to 4 over x. Okay, so the lower limit should be y equals to 4 over x. All right, and the upper line here, this line is y equals to x. Okay, so we have y equals to x. And then how about the x, limit of x from where to where? The points now. Limit of x. Yes, from 2 until 4. Okay. So let's proceed with the integration. 2 until 4. Okay, now the constant is x. So x can be taken out. Y squared over 2. Substitute y equals to x and then 4 over x dx. Okay. So we will have 2 until 4 x squared over 2 minus 4 over x. So 16 over x squared should be 16 divided by 2, 8 over x squared lah. Macam tu. Dx, so multiply everything with x. X cubed over 2 minus 8 over x dx. Okay, so now we can integrate this happily. We will have x to the power of 4 over 8 minus, ni, integrate ni dapat apa ni?
8x negative 2.
No, that's integration, that's differentiation. Yes, you will get ln. Never mind, good response. I like when you respond my question. So 8 ln x, okay? So now we have 2 until 4. Let us proceed. 4 to the power of 4. So 4 to the power of 4, 16, isn't it? X kuasa 4 kuasa 4, 64. 64 bahagi 8. 64 salah. Kalau X kuasa 4, sekejap 256. 256, isn't it? 256. Oh, 32 nanti kalau kecilkan. Alright. Minus 8 ln 4 minus 2 kuasa 4, 16. 16 per 8 tolak 8 ln 2. Berapa tadi juga 32 Yang ni 25, 32 tolak 8 ln 4 minus 2 plus 8 ln 2. So we have 30 minus 8 ln 4 plus 8 ln 2 should be 30 minus ke? So let's say we have 8 ln 2 divided by 4 lah macam ni kan. Suppose we will have 30 plus 8 ln half or 30 plus 8 ln to the power of negative 1, isn't it? So we will have 30 minus 8 ln 2. Either one lah. Actually, you can leave your answer like this. It's already enough lah. Yang ni pun betul juga. Either one. Okay. So next question. Question mana yang lebih crucial lagi? 2x. Okay, let's say we have look at question number 8. We just set the integration, guys. Okay, question number 8. Okay, highlight the keywords here. We have second quadrant between a circle and the line. All right. So we have this region R. X and Y. Okay, circle. What's the radius of this circle?
3.
3. Okay, good. 3. Alright, so sorry. So we have a circle with radius 3. Here 3, 3. Okay, now line y equals to x plus 3. So if you use intercept form, y minus x equals to 3. So y over 3 minus x over 3 equals to 1. So x equals to negative 3, isn't it? So we will have this line. I will use blue color. So we have this line. Okay. So the question asks you to find the region in the second quadrant. So second quadrant, of course, inilah. This one. Okay. So right now, which one you want? DYDX or DSDY? I'm sorry, this question already gives you the choice DYDX. So just follow the question. Okay, so DYDX means the movement is from bottom line to the top line. Okay, bottom line to the top line. So we have y dy dx. Okay, the lower line is y equals to x plus 3. And then the upper line, okay, the upper line is belongs to this circle, s squared plus y squared equals to 9. Therefore, y equals to square root of 9 minus x squared. Okay, so square root of 9 minus x squared. Okay, and the limit of x from where? Give me the point. X from?
-3 to 3.
Not 3, it just stop here. Yes, very good.
Zero. Negative 3,
Yes,
0.
yes, from negative 3 until 0. Well done. Okay, so I think you can proceed this integration on your own. All right, so question number 9, number 10 is quite simple. Okay, let's say we do question number 11 for the volume. Okay, we have volume here. All right, oops. So let us do question number 11 before we proceed to topic 4.4. Okay, first of all, guys, volume equals to double integration towards region R. We have fxy dA, which means that fxy is your z actually. Okay, so in this case, we have x plus y plus 2z equals to 6. Therefore, 2z equals to 6 minus x minus y. Therefore, z equals to, divides everything by 2. We have 3 minus x over 2 minus y over 2. Okay, so that is your z. All right, now the concept for this is, okay, first of all, let us sketch the region. We start with 3D region. X plus y plus 2z equals to 6. So we have x over 6 over 3 equals to 1. So in 3D, you have something like this. All values are positive. Okay, we have x equals to 6, y also equals to 6, and z equals to 3. So we have this plane. Okay, always bear in mind, guys, when we have R, region R means 2D. 2D, two dimension, means x and y exist. XY plane. Okay, so x and y exist. If you look from above, we can see this region. This region, isn't it? This is your region R on X and Y axis. So if we sketch region R, X and Y, X equals to 6 and Y also equals to 6. We have this region. Okay. So we have for this line is represented by X over 6 plus Y over 6 equals to 1. Okay. So now let us proceed with the volume equals to double integration. Okay, fxy equals to z. So this is your z. Okay, z equals to 3 minus x over 2 minus y over 2. Okay, now you want dy dx or ds dy? This is your region R. Ni region R. So which one?
dy dx.
Boleh. Yang ni boleh dua-dua doesn't mind. Dy dx. Okay, if you want to dy dx. Okay, can you give me the limit? The lower limit of y? Y from?
X equals 0.
What? Y equals to 0. Okay, good. Until y equals to?
6.
6 minus X.
This line ni line. Ingat, dalam ni kat luar ni mesti lines, garisan. Okay, so this lines and this line. Okay, from bottom to top. So that line is x plus
Minus
y equals to 6. Yeah, so y equals to 6 minus x. Okay, so the limit of y is 6 minus x. Okay, and then the limit of x should be from 0 until 6, yes. Okay, so I think you can proceed this with, on your own, right? It's just very simple, just polynomial, so you can proceed lah. Okay, we have 1 hour to discuss 4.4. Don't worry guys, if you have problem regarding to exercise 4.3, just WhatsApp me. Okay, WhatsApp me personally. I'll show you the solution. All right, so 4.4 is double integrals in polar coordinates. Right, double integrals in polar coordinates. So 4.4 double integrals. Oh, before that, sorry guys. We have to discuss about reverse the order of integration. This is also important. Sorry, reverse the order of integration. This will come out in your quiz 4 and also final exam. Okay, so let us learn how to reverse the order of integration. If you are given dy dx, then you have to change to dx dy or vice versa lah. Okay, so I would like to repeat. All right, if you have dy dx, so this is the limit. Here should be lines, and here should be points. And then from bottom to top. Okay, the arrow must be from bottom line to top. Okay, and then if you have dx dy, the movement should be from right to left. Right lines to the left line. So here also lines. You have to bear in mind garisan. Dekat luar ni baru titik je, points. Titik saja. Okay. So how to reverse the order of integration? Let's take a look at this question. Okay, let us start with a very simple one. Question number 15. Okay, first of all, in order to reverse the order of integration, okay, so right now in this case, you are given dx dy, okay, so basically you need to change, okay, reverse order So you have to find the integral in dy dx. Okay, but you cannot simply or switch the limit. You cannot just switch the limit because this is for the case of non-rectangular region. Kalau subtopic 4.2, you boleh switch je sebab both of the limits are constants. But now dia melibatkan a function, so you have to sketch the region first. Okay, so as usual, we take out the limit. We know that x from y minus 2 and then y equals to 0. Okay, guys, so we have x equals to y minus 2 and then x equals to 0. Okay, and the limit of y is from 0 until 2. Okay, so let us sketch the region. Region R, so x and y. Okay, so x equals to y minus 2. X equals to y minus 2. So we will have x minus y equals to negative 2. So negative x over 2 plus y over 2 equals to 1, isn't it? So we will have a region here, x equals to negative 2 and then y equals to 2. So this is the straight line. Okay. And then y from 0 until 2. Okay, from 0 until 2. So this is the region. Okay, this is the region. All right. So now we want to change into dy dx. So into dy dx means the movement is from bottom to top. So from bottom line to the top line. Okay. So we will have limit of integration. Therefore, the answer is, okay, fxy, just copy it down because no need for you to calculate. You just need to change into dy dx. So the lower line should be y equals to?
0.
Yes, y equals to 0. How about the upper line?
X plus 2.
Yes, okay, y equals to x plus 2. Well done. Okay, y equals to x plus 2. How about limit of x from?
Negative 2 until
Negative
0.
to 0.
Yes, negative to 0. That's it. That's the answer. Okay. So next question. Okay, let's do question number 17. Question number 17. Okay. We have, right, this is quite interesting. Okay, so in order to reverse the order, okay, dx dy, so reverse order, you need to find dy dx, okay, dy dx. So what happened here, guys? X equals to ln y and x equals to 0, okay? And then limit of y is from exponent negative 2 equals to 1. Okay, can you give me the decimal number of exponent negative 2? Exponent negative 2 is equivalent to what? If you change to decimal number, use your calculator.
0.135.
0.135.
135. Okay, good. Well done. Thank you so much. Okay, so let us plot these two graphs. Okay, we have x equals to ln y and x equals to 0. So let us plot the graph. Graph of ln. Okay, should be positive ln y. Y equals to 1, ln 1 is 0. Okay, so we will have something looks like this. All right. We have x, we have y here. Of course, when x equals to, okay, when y equals to 1, x equals to 0, yes, okay. And then y equals to 1, exponent negative 2 is this one, listen here. So 0.135 is below than 1, isn't it? So we have exponent negative 2 here. Exponent negative 2 bawah ni. Sekejap lah, saya lukis balik ni. 4. Sekejap bagi you nampak sikit. Okay. Saya ke ataskan sikit lah. Alright, so here. Okay. Let's say here is 1 just now, and here is exponent negative 2. Okay. So x equals to 0. X equals to 0 is y-axis, isn't it? Y-axis. Okay, so now we want to find the position when y equals to negative 2. Okay, since x equals to ln y, thus when y equals to exponent negative 2, we have x equals to ln exponent negative 2. So we will have x equals to negative 2, isn't it? So x equals to negative 2. We will have somewhere here, negative 2. And then x equals to 0 is here. X as this. So we have this region. Okay, we have this region. Right? Understand this, guys?
Yes.
Okay. So now, all right. Now let us reverse the order. Okay, reverse the order. Right now, we want to find dy dx. So the movement is from right to left to right or bottom to top?
Left to right.
Dy dx. Dy first.
Bottom to top.
Bottom to top. Okay, good. Bottom to top. So bottom to top. Okay. So now we have fxy dy dx, bottom to top. So bottom line is this. Okay, so y equals to what? Bottom line.
Exponent negative 2.
Yes, exponent negative 2. Until the upper line is this curve. So y equals to, okay, since x equals to ln y, thus y equals to exponent x, isn't it? So we have y equals to exponent x. How about limit of x? From?
Negative to 0.
Yes, negative to 0. Okay, that's it. So understand the reverse order of integration? Do you understand, guys? Reverse order of integration?
Yes.
Okay, good, well done. So now we can proceed to 4.4 double integrals over double integrals in polar coordinates. In polar coordinates. Okay. So let us do, okay, first of all, okay, before this we have double integrals to origin r fxy dA, isn't it? So right now in polar coordinates, we will have again region r, but our function would be in r and theta. And then for dA ni guys, before this kita ada, we have dy dx and ds dy. However, in polar coordinates, we have three terms, r, dr, d theta. That is your dA. Okay, ingat dA adalah r, dr, d theta. Three siblings, tiga beradik ni. Nah, itu kalau dalam polar. Okay, so now let us proceed to exercise 4.4. Okay, exercise 4.4. Let us do question let's say we do question number 2. Question number 1 is very simple sangat lah. Kita buat question number 2. Copy. Okay, question number 2. Alright, first of all, we need to take out the limit. Always bear in mind, your region R 100% from the limit. This is your region R. Okay, so in order to sketch the graph, you should refer to the limit, not the function dalam tu. Tapi adalah, you kena refer limit, baru you will sketch the region. Okay, so limit R, of course, we have R here from 1 and 2. Okay, so region R equals to 1 and R equals to 2. Okay, and then theta is from pi over 2 until pi. So let us sketch the region. Guys, R equals to 1 dengan R equals to 2 ni apa sebenarnya? What's the shape? Tak ingat lah, chapter 1. Circles, yes, well done. It should be circles, yes. Okay, R equals to 1 is circle with radius 1. R equals to 2 is circle with radius 2. So let us sketch the circle. Okay, we have 1, radius 1, and then we have second circle as radius 2. Okay, so right now it said that the limit of angle is from pi over 2 until pi. So theta equals to pi over 2 is up here. Pi over 2 until theta equals to pi here. Okay, therefore the region should be this. You lorek kat region tu. Okay, so that's the region. Okay, region R. This is your region R. Okay, so now we can proceed with the integration. Pi over 2 until pi, 1 until 2 r dr d theta. This is quite simple. So pi over 2 until pi r squared over 2, substitute 1 and 2, dr d theta, dr tak ada lah, d theta. So we will have from pi over 2 until pi, so 2 squared, 4 over 2, so 2. Buat je macam ni, 4 over 2 minus 1 over 2 d theta. So we will have 3 over 2, isn't it? So 3 over 2 times theta, substitute pi and pi over 2. 3 over 2, pi minus pi over 2, you will have 3 over 2, pi over 2, so we will have 3 pi over 4. Okay, that is the correct answer for this question. Okay, so we have this 3 pi over 4. Alright. Now let's take a look at question. Macam mana yang mencabar lagi? Okay, let us do question number 3. This question. Again, you have to refer to the limit in order to sketch the region. So we have R from 0 until 4 sine theta. Okay, so R equals to 4 sine theta. Okay, and R equals to 0. Of course, we will have this region. X and Y. So 4 sine theta should be up here, isn't it? On what axis? We have 4. Okay, however, this is not a complete circle because the angle theta is from 0 until pi over 3, just until pi over 3. So theta equals to 0 is here. Pi over 3 is 60 degrees, so we will have until here. Theta equals to pi over 3. So your region would be only this. Okay? Understand, guys? How to sketch the result?
Yeah.
Okay, so let us proceed. 0 until pi over 3. Of course, R just cos theta is just a constant, so we can take out cos theta. So you integrate R squared over 2. Substitute 0 and 4 sine theta, so d theta. Okay, so we will have from 0 until pi over 3. Let's say 1 over 2 taken out, cos theta, substitute 4 squared. 4 squared, so 16 sine squared theta minus 0, of course, d theta. So we will have, okay, 2 times 16, we have 8. Okay, so dia akan jadi 0 until pi over 3, 8 cos theta sine squared theta, d theta. Okay, tell me, how do we integrate this? Any idea? Come on, my brilliant students. Pelajar-pelajar yang bijak pandai, engineers belaka ni, scientists. How do we integrate this? Senyap je. Guys, macam mana nak integrate ni? Any idea?
No.
I appreciate your response. Okay, so what you can do is you need to have a substitution. Okay, we let u equals to sine theta. All right, so differentiate u, we get cos theta d theta. Okay, so of course we will have d theta equals to du over cos theta, isn't it? And then, okay, I like to change the limit. So when theta equals to pi over 3, we will have u equals to sine pi over 3. So we have u equals to sine 60, square root 3 over 2, isn't it? And then we have when theta equals to 0, u equals to sine 0 is 0. Okay, so we can change this integration into from 0 until square root 3 over 2. Okay, so we have 8 cos theta, 8 cos theta. Okay, so this one becomes u squared, isn't it? So sine squared becomes multiplied by u squared. Okay, u squared, u squared, okay, and then d theta is du over cos theta. Okay, d theta is du over cos theta. So we will have du over cos theta. So we can cancel this. Cancel and cancel. So we will have integration from 0 until square root 3 over 2. 8u squared du, isn't it? So we can integrate this happily. So 8 times u cubed over 3, substitute square root 3 over 2 and 0. So we have 8. Okay, let's take out 1 over 3. So square root 3 over 2 cubed minus 0. Okay, question number 3. So we will have multiply, this becomes 4. Okay, 8 divide 4 over 30. 2/3. So we will have 4 over 3 square root 3 cubed. So 3 square root 3 like this. And then we can cancel this, isn't it? So we will have 4 square root 3. Betul ke cepat ni? Square root 3.
Then why did you cancel the
Mana? Cancel?
Boleh ke
Number
cancel
two.
ke madam?
Mana? Which one?
but it's in the brackets is kuasa 3.
Oh, I see. Oh my God. Patutlah jawapan salah. Thank you. Saya tak ternampak benda ni. Di dalam kurungan kan. Okay, good. Thank you so much. 8/3, baru cantik. So this one jadi square root 3 kan. This one jadi 2 kuasa 3. Macam tu. Okay. So 8/3 multiplied by 3 square root 3/8, isn't it? Kan 2 kuasa 3 lah.
Good.
Alright, so we have this and this. Patutlah jawapan lain. Alright, so square root 3. Understand this
Yes.
question? Okay, good. Thank you very much. Okay, next. Closest integral. Ni simple question number 6, 7. Alright, let us do question number 8. Number 8 ini susah sikit. Question number 8. Okay, we have a circle. Okay, this is a circle. And above the line y equals to 1. So first of all, let us sketch the region. Okay, sketch the region R. X and Y. So a circle. What's the radius of this circle, guys? What's the radius? R equals to? 2. Okay, good, very good. R equals to 2 here. Next, y equals to 1. The line y equals to 1. Of course, we have a line here. Line y equals to 1. Let's say here is 1. Okay, so we have this region. We will shade this region. Okay, right now you need to find the angle of intersection. Oh, sorry. You have to find the angle of intersection because it's intersect between these two lines, right? So you need to find what's the angle here and what's the angle here. Okay, so find the angle of intersection. Okay, so you need to equate both R equals to R1 equals to R2, isn't it? So first of all, we have x squared. Okay, x squared plus y squared equals to 4. Therefore, we have r squared equals to 4. So r equals to 2. And then we also have the second equation, line y equals to 1. What's the polar equation of y? Still remember chapter 1. What is the polar equation of y? Dalam bentuk r dengan theta. Yes, very good. R sine theta equals to 1. Therefore, the second r should be 1 over sine theta. Okay, so we equate R1 and R2, right? R1 equals to R2, so 2 equals to 1 over sine theta. Therefore, we have sine theta equals to 1 over 2. Therefore, theta equals to r sine of 1 over 2, which is equals to 30 degrees, isn't it? Or pi over 6, right? Okay, so we know that from here, this is theta pi over 6. How about this? How about this, guys? The other angle. Kat sini.
7 pi over 6.
Not really. Why you have 7 pi over 6? Okay, if you have theta 1 equals to pi over 6, should be here, right? Pi over 6. So how do we find this angle? Theta 2 is pi minus pi over 6, isn't it?
Yes.
So we will have 5 pi over 6. Okay, it's okay, nice try. Thanks for responding to me. So we have 5 pi over 6. Okay, so now let us find the area. Okay, area E double integrals towards region R dr d theta. That's the formula of area. So we will have r dr d theta Okay, what's the limit of R now? Guys, cara kira R is starting from this line. Okay, this line ni, line ni. R. Until this line. Okay, so the first line is belongs to y equals to 1. Okay, so the lower limit should be R equals to 1 over sine theta. Alright, so 1 over sine theta is actually equivalent to cosecant theta. Okay, so the lower limit should be R equals to cosecant theta. Alright, and the upper limit of R should be equals to what?
Square root. Uh, I don't know.
Of course, R equals to 2 lah. Kan 2 ni garisan atas ni. Saya pakai pink color ni. Ni garisan atas. R equals to 2 lah. Of course, the circle equals to 2, isn't it? Alright, the green color is lower line. That's why kita ambil daripada y equals to 1 tadi ni. Y equals to 1. So we know that y equals to 1. We have r sine theta equals to 1. So r equals to 1 over sine theta equals to cosecant theta. However, for the upper line, of course, radius equals to 2. So the upper limit of r should be 2. Understand?
Yes.
Okay, good. So now, angle is from pi over 6 until 5 pi over 6. Okay, so pi over 6 until 5 pi over 6. Okay, or kalau you tak suka 5 pi over 6 ni, apa lagi cara lain you boleh buat? You can divide by 2, isn't it? Sebab dia symmetry kan, it's symmetry graph. So you can consider from angle equals to pi over 2 kan? Sampai pi over 2. Okay, so or alternatively, okay, area equals to 2 times, darab 2 kali ganda lah, pi over 6 until pi over 2. We have cosecant theta until 2 rd theta. Okay, like this. So let us proceed. So 2 times pi over 6 until pi over 2. R squared over 2. So we will have 2 and then cosecant theta d theta. So we will have 2 4 divided by 2 is 2, isn't it? So 2 minus 1 over 2 cosecant squared theta d theta. Okay, so now we will have, if multiply by 2 everything, pi over 6 and pi over 2. 2 times 2 is 4 minus cosecant squared theta d theta. Okay, so we will have 4 theta. Integrate cosecant squared. Integrate cosecant squared. Kalau you refer to your module tu guys, page last kali tu, kita ada appendix tau. Wait a minute, I will scroll until page last kali tu, kita ada appendix of the formula of integration. Kalau you ada beli modul kan? Kalau you perasan, belakang ni ada appendix ni. Kita tengok integration of cosecant squared. Okay, integration of cosecant squared. Yes, we have this. Copy. Paste. Right. Integrate of cosecant squared, we get negative cotangent. So, ni saya highlight sikit lah. Okay, so kita integrate negative cosecant. So, dia akan jadi positive cotangent lah kan? positive cotangent theta. Substitute pi over 2 and pi over 6. Cotangent is equivalent to what, guys?
1 over tan.
Yes, 1 over tangent theta. All right, so let us substitute the limits. Jom, take out your calculator. Okay, for pi over 2, so should be 2 pi plus 1 over tangent pi over 2 minus 4 pi, so 2 pi over 3 plus 1 over tangent pi over 6. Okay, so tangent 90 should be 0, isn't it? Tangent 90 ni dia adalah 1 over infinity ni sebenarnya. So 2 pi plus 1 over infinity, you go. And then 2 pi over 3 plus 1 over tangent 30 degrees should be equals to square root 3 over 3. Square root 3 over 3. So this one should be 0. 1 over infinity is 0. So 2 pi minus 2 pi over 3. 2 pi, 2 kali 3, 6. 6 tolak 2, 4 pi per 3. And then minus, minus 1 over square root 3 over 3 is actually 3 over square root 3, isn't it? So we will have 4 pi over 3 minus 3 bagi square root 3 should be square root 3 lah. Okay, so we have this answer. Okay, so that's it. That's for question number 8. Kalau keluar soalan final exam macam ni, boleh jawab tak guys? Agak-agak. There is one semester, this type of question come out in final exam. Pernah sekali keluar lah soalan macam ni. Okay. So, Allah, patah balik semula. So, let's take a look at exercise 4.4 again. Sorry lagi ni. Kita tengok soalan question number, I think number 10. Question number 10. Mana lambatnya? Question number 10, okay. Oh, before that, question number 9 ni. Semicircle. Nampak susah tapi sebenarnya senang soalan nombor 9 ni. Okay, question number 9. Alright, first of all, of course, you need to sketch the region R. Therefore, this is your region R, semicircle, okay, region R. So we will have X and Y. We have a circle with, okay, here Y equals to square root 9 minus X squared. So we know that Y squared plus X squared equals to 9. So the radius should be equals to 3, isn't it? So 3, 3, negative 3, and negative 3. Okay, we know that Y must be greater or equals to 0. So of course, the region just a semicircle here. Okay, so can you give me the bounded angle? Angle from where to where?
0 to pi.
0 to pi.
0 until pi. Okay, well done. I'm happy with that. So 0, okay, angle equals to 0 until angle equals to pi. All right, so let us proceed with the integration. Okay, so we will have region R exponent of negative 2x squared plus y squared dA. Okay, so we know already that this is equivalent to r squared. Okay, this is actually r squared. Okay, and then dA is what? Remember, tadi saya dah pesan, dA ni berapa beradik ni?
R dr d theta.
Yes, r dr d theta. Okay, so let us convert this into polar coordinates. Okay, we have exponent negative 2r squared, and then we have dA is r dr d theta. Okay, now the radius, the limit of radius, r from where to where, according to this graph? Always bear in mind r start from 0. Okay, so radius is from 0 until 3 because here we have this 0 until 3, 0 until 3, 0 until 3, 0 until 3. Okay, so radius from 0 until 3. How about the angle? From, tadi you order cari ni, 0 until pi. So we have 0 until pi. Okay, now let us proceed. How do we integrate this? Any idea, guys? How? Come on, my students. How do we integrate this? Again, you have to make a substitution. We let u equals to negative 2r squared. Okay, so differentiate u, we will get negative 4r dr. Okay, therefore dr equals to negative du over 4r, like that. So when r equals to 3, we have u equals to negative 2 times 3 squared. So negative 18. And then when r equals to 0, we will have u equals to negative 2 times 0 squared. So it will be 0. Okay, so let us change this. Equals to 0 until pi is maintained because we don't integrate with respect to theta yet. We just integrate with respect to r. So we just change the limit. Okay, guys, listen here carefully. We have 3 here. So when r equals to 3, we have limit of negative 18. So we should put negative 18 at the position of 3. And then the second one, we have r equals to 0. So when r equals to 0, we have u equals to 0. So we have 0 here. And then exponent negative 2r squared. Okay, negative 2r squared becomes your u. Okay, so exponent u and then multiply by r. Okay, dr. Now, dr equals to negative du over 4r. So negative du over 4r. D theta, just copy it down. Okay, so now we can cancel this r and r. So we have negative 1 over 4, isn't it? So negative 1 over 4 can be taken out. Then 0 until pi, 0, negative 18. So exponent u du d theta. Okay, now integrate exponent u, we can get exponent u, right? Jadi exponent u juga lah, tak ada effect sebab perkali dia satu. So exponent u integrate, gantikan 0, negative 18 d theta. So negative 1 over 4, integrate 0 until pi, exponent negative 18 minus exponent 0 d theta. So this is equivalent to 1. Okay, so we can take out all the constants, all right, negative 1 over 4, exponent negative 18 minus 1. So we just integrate 0 until pi d theta. So if I change, it becomes positive 1 over 4, 1 minus exponent negative 18. Integrate 1 with respect to theta, we get theta, of course. So substitute pi and 0. So we will have pi over 4, 1 minus exponent negative 18. Okay, so that's the answer. Understand, guys, for this question?
Yes.
Okay, good, well done. And then next question, That is the question number 10. Copy. Okay, read carefully. Okay, the keywords here is first quadrant. All right, and then you have 3 lines. X equals to 0, y equals to x, and x squared plus y squared equals to 4. Okay, guys, so let us sketch the graph. Oops, sorry. I'm going to use this for the axis. We have x squared plus y squared equals to 4. So we will have a circle with radius 2. Okay, circle with radius 2. We have 2 here, 2 here. Okay, and then we have y equals to x. Y equals to x is this straight line. Okay, straight line. Y equals to x. Okay. Now, where is the line of x equals to 0, guys? X equals to 0 means what?
Y-axis.
Yes, y-axis. Okay, so y-axis. So we will have this line, y-axis yang kat sini. Ini penting so that you tahu you nak lorek kat mana. So which part? The upper part or lower part?
Upper.
Upper part, yes. This region. Dia ada bounded by ketiga-tiga garisan tu. Number 1, y equals to x. Y equals to x dengan ni, circle ni. Dia ada tiga-tiga tu. Okay, so that is your region R. This is your region R. Okay, now, how do we find the angle? The angle, how do we find the angle? From where? We have to take from here, isn't it? Theta equals to what? So from this line, okay, we have equation y equals to x. All right, so y equals to x. So y is r sine theta, isn't it? And then x is r cos theta. Macam tu. So sine theta divides by cos theta equals to 1, right? R bagi r dapat 1 lah. So tangent theta equals to 1. Therefore, theta should be arctangent of 1. So equivalent to what?
45.
Yes, 45 degrees. Okay, 45 degrees or equals to pi over 4. Okay, so therefore we will have the angle here should be pi over 4. Okay, until sampai mana?
Pi over 2.
Yes, well done here. Okay, theta equals to pi over 2. So theta is from pi over 4 until pi over 2. Okay, like that. All right, so let's proceed with the integration. Integration, yang ni kita ada function 1 plus. Okay. Region R, 1 plus 2 plus x squared plus y squared. dA, isn't it? Okay, dA. Okay, now saya nak you yang bagi. Okay, 1 per, bawah ni apa? 2 plus? What is it?
R squared.
Yes, r squared. Okay, next, how about this? dA is?
R dr d theta.
Yes, r dr d theta. Okay, now the limit of radius. R from where to where? We start from origin, isn't it?
0 to 2.
0 to 2, right? Radius is 2. So 0 until 2. How about the angle? Of course, the angle yang tadi lah. So pi over 4 until pi over 2. So let us proceed. Now, how do we integrate this? Dah banyak dah saya bagi tips hari ni. Macam mana nak integrate soalan ni?
Let you. Good.
Yes, let you, betul lah. Let you equals to what?
2 plus R squared.
Yes, 2 plus r squared. Very good. So differentiate u, we will get Differentiate 2, we get 0. Differentiate r squared is 2r dr. Okay, therefore dr equals to du over 2r. Alright, so now when r equals to 2, we will have u equals to 2 plus 2 squared. So 4 plus 2 is 6. And then when r equals to 0, we have u equals to 2 plus 0 squared. So we have 2. Okay, so we can change this. Okay, as usual, angle is maintained pi over 4 and pi over 2. We just change this one. Okay, from 2. Okay, so r equals to 2 change to u equals to 6. Okay, because of this, r equals to 2, u equals to 6. And then r equals to 0, we get u equals to 2. Okay, so 2 down here. After that, okay, 1 over 2 plus r squared is your u. Okay, so we have 1 over u multiplied by r. Okay, dr is du over 2r. Okay, du over 2r. So du over 2r. D theta, maintain lah. D theta tak ada apa. Okay, next we can cancel this and this. Okay, so we can take out the coefficient. So 1 over 2 can be taken out. So we have pi over 4, pi over 2, and then 2 and 6, 1 over u du d theta. Okay, how do we integrate this? Integrate 1 over u dapat apa, guys?
Lon U.
Yes, very good. Ln u. So substitute 6 and 2 d theta. Alright, so we have 1 over 2 integration from pi over 4 until pi over 2. Ln 6 minus ln 2 d theta. So of course this one, ln 6 minus ln 2 is ln 6 over 2. So we have ln 3. Okay, so we have ln 3. So ln 3 is just a constant. So 1 over 2 ln 3. Integrate pi over 4 until pi over 6. We have 1 d theta. So integrate 1, we get theta lah, of course. Substitute pi over 6 and pi over 4. Pi over 2. Main mana pula pi over 6 ni? sorry guys. So here pi over 2. Okay, so 1 over 2 ln 3 pi over 2 minus pi over 4. So you ada apa ni? Pi over 4, 2 minus 1. So pi over 4 lah. 1 over 2 ln 3 multiplied by pi over 4. So we will get pi over 8, isn't it? Pi over 8 ln 3. Okay, that's it. That's the answer. Alright, so that's question number 12. So jom kita buat soalan macam ni pula. Okay, for question number 11 ni, kalau let's say kita sketch graph saja lah. Okay, y equals to square root. Okay, so we will have this region. Values here is 3, isn't it? So semicircle ni belah mana? Right, left, upper part or lower part? For question number 11 ni. Should be upper part, isn't it? Sebelah atas je.
Yes.
So yang ni lah, negative 3. So bila you nak convert, you akan jadi apa ni? Integration of this one jadi r squared. Ini dy dx ni akan jadi r dr d theta lah. And then limit of r from 0 until 3 and then 0 until pi. Okay. Ni, you kena ingat ni. This one, dy dx ni adalah dA. Okay, so bila dia dA, dia adalah r dr d theta. Ini. Okay. Now, question number 12. Ni, question number 12. Sebelah mana semicircle ni? What's the radius now? 1, right? You faham ke tak apa saya buat ni? Ni, this one guys, this one. Okay, x equals to negative square root of 1 minus y squared, isn't it? So if you square both sides, you will get x squared plus 1 minus y squared. So x squared plus y squared equals to 1. So that's why we have a circle with radius 1. However, it said that x from negative until positive sampai 0. So sebelah mana ni? Saya ni circle je lah ni. Okay, part cy negative 1. Betul dah, part cy. Y from negative 1 until 1, betul dah. So where is it?
Bawah.
Bawah. Are you sure bawah? Left side, yes.
Atas.
Bukan atas. Guys, macam ni. Ini kan ke x, dx ni kan? X ni from left to right, isn't it? Ingat tak tadi kita belajar? X from left to right. So x daripada negatif square root of 1 minus y squared sampailah ke 0. So garisan ni, ini adalah negatif 1 minus y squared until 0. 0. So we just have left side. Ni je kawasan kita. Ni je region kita for question number 12. Okay. So bila kita dia suruh convert kepada polar, nak convert macam mana ni? Integration, question number 12 ni. Yang tengah-tengah ni jadi apa? Square root of x squared plus y squared. Jadi apa guys?
R square.
Jadi R.
Jadi R. Kan? Square root kan? Jadi R. Lepas tu darabkan dengan dx dy tu jadi apa?
R d theta.
Yes, R d theta. Okay, now the radius from start
Pi
from origin.
Pi over
0 until 1. Okay, kan circle radius dia start from origin sampai 1. Ni 0 until 1, 0 until 1, 0 until 1. Like that, 0 until 1. Macam tu. Okay, and then how about the angle? Limit dia from where to where ni? Berdasarkan region kita ni.
Pi over 2.
Yes, good. Theta from pi over 2 until
3 pi over 4.
3 pi over 2. 3 pi over 2, kan? Okay, so from pi over 2 until 3 pi over 2. Understand guys how to convert this?
Inshallah.
Okay, so alright, so I think that's all for today, guys. Don't worry, you can do the rest of the questions, and if you have any problem, you can WhatsApp me personally. Okay, I will help you. Alright, so thank you very much for your attention. For the Muslim, we finished with Tasbih, Kafara, and Surah Al-As.